Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about ready-mix concrete. Concrete is one of the major components of a structure, particularly a multi-storied structure, wherein it accounts for 30–50% of the total cost. The quality of concrete has also a very direct bearing on the strength and durability of the structure as a whole. It is in this context that RMC assumes relevance. Few things are more aggravating to produce on a work site than concrete. Bags of cement, sand, aggregate, gravel, and possibly other additives must be delivered to the construction area. A supply of clean water is also necessary, along with current concrete mixing hopper. Even after all the dusty and heavy ingredients have been loaded into the hopper, one small error in the wet-dry ratio can render an entire batch of concrete unusable. One common solution to this messy and time-consuming problem is ready-mix concrete. RMC is a specialized material in which the cement aggregates and other ingredients are weigh-batched at a plant in a central mixer or truck mixer, before delivery to the construction site in a condition ready for placing by the builder. Thus, fresh concrete is manufactured in a plant away from the construction site and transported within the requisite journey time. The RMC supplier provides two services, firstly one of processing the materials for making fresh concrete and secondly of transporting a product within a short time. This technique is useful in congested sites or at diverse workplaces and saves the consumer from the botheration of procurement, storage, and handling of concrete materials. Ready-mix concrete is produced under factory conditions and permits a close control of all operations of manufacture and transportation of fresh concrete. Due to its durability, low cost, and its ability to be customized for different applications, ready-mix concrete is one of the most versatile and popular building materials. RMC is usually ordered in units of cubic yards or meters. The use of the RMC is facilitated through a truck-mounted boom placer that can pump the product for ready use at multi-storied construction sites. A boom placer can pump the concrete up to 80 meters. It must remain in motion until it is ready to be poured, or the cement may begin to solidify. The RMC concrete is generally released from the hopper in a relatively steady stream through a tough system. Workers use shovels and hose to push the concrete into place. Methods of production. There are two general methods of producing RMC. Transit or truck mixing. Central mixing. Shrink mixing. Transit mixing. In transit mixing, the dry materials are proportioned at the RMC plant, the water being added and the mixing done en route to the job in a truck mixer, which essentially consists of a mixer drum mounted on a conventional chassis. Power for rotating the drum is obtained either from the truck engine or from an independent petrol engine. The truck mixer is provided with a water supply tank with equipment for measuring the quality of water entering the drum, and a revolution counter indicating the extent of mixing. As soon as the mixer drum is charged with its complete batch of materials from the batching plant, the truck proceeds to the concrete pouring point, the mixing operation taking place en route, the water level and the mixing controls being operated by the driver, where the length of the haul is long. Delivery of freshly mixed concrete is assured by starting the mixing operation towards the end of the haul. On arrival at the work site, the concrete is discharged over detachable chutes into receptacles or directly onto the forms. Central mixing. In central mixing, both the operations of proportioning and mixing are carried out at a batching plant and deliver the mixed concrete to the site in an agitator truck, which keeps the mixed concrete in correct form. In case of centrally mixed type, the drum carrying the concrete revolves slowly so as to prevent the mixed concrete from segregation and prevent its stiffening due to initial set. Central mixing is resorted to when there is likely to be a considerable period lag between the time of mixing and the time of placing. With agitation, a maximum of 1.5 hours between mixing and placing can be allowed. Another important consideration in favors of central mixing method is the fact that more concrete can be transported in a single trip when the truck mixer is used as an agitator. The effect of this is to reduce the transportation charges, all other factors being equal. Shrink mix. Concrete that is partially mixed in a plant mixer and then discharged into the drum of the truck mixer for completion of the mixing is called shrink mixed concrete. Central mixing plants that include a stationary, plant-mounted mixer are often actually used to shrink mix, or partially mix the concrete. The amount of mixing that is needed in the truck mixer varies in these applications and should be determined via mixer uniformity tests. Generally, about 30 turns in the truck drum, or about 2 minutes at mixing speed, is sufficient to completely mix shrink mixed concrete. Placing of concrete. Materials required for RMC. Admixtures, a substance added to the basic concrete to alter one or more properties of the concrete, i.e. fibrous materials for reinforcing, water-repellent treatment and coloring compounds. Air entrainment admixtures, mainly used in concrete exposed to freezing and thawing cycles. Water-reducing admixtures, plasticizers, reduce the dosage of water while maintaining the workability. Retarding the admixtures, mainly used in hot weather to retard the reaction of hydration. Superplasticizer or high-range water reducer, significantly reduce the dosage of water while maintaining the workability. Miscellaneous admixtures such as corrosion inhibiting, shrinkage reducing, coloring, pumping, etc. Aggregate. Inert particles, i.e. gravel, sand, and stone, added to cement and water to form concrete. Cement. Dry powder that reacts chemically with water to bind the particles of aggregate, forming concrete. Portland cement is typically used in concrete production. Fly ash. Fly ash is a byproduct of coal-fired electricity generating power plants. Mainly composed of combustible elements such as carbon, hydrogen, and oxygen, nitrogen and sulfur being minor elements, and non-combustible impurities, 10 to 40%, usually present in the form of clay, shale, quartz, feldspar, and limestone. Ready-mix concrete plant. A ready-mix concrete plant is a permanent installation with mechanical handling for the storage, proportioning and mixing of materials. The location, size of the plant and layout are governed by a number of considerations, depending upon local conditions which require careful study before the design and construction of the plant are undertaken. Location. In the operation of a RMC concern, the transportation of the concrete to the site of the job is generally one of the most expensive items, and the RMC plant should, as far as possible, be situated in the center of the market. This may be a difficult proposition in a very large cities where works requiring RMC may be situated beyond the economical radius for operations. In such cases, it may prove more economical to operate 2 or more small plants, spread out to reduce the length of the haul, than to concentrate production in a single large plant. Another important consideration in the selection of a site is the facility of delivery of materials to the plant. Location near the railhead, from which a siding can be constructed to the plant, would be more advantageous in unloading the materials direct from the wagons to their respective stockpiles. Size of plant. The size of plant will depend chiefly on the potential demand for which the plant has to cater. This in turn is dependent upon the quality of concrete construction carried out in a town or city. Towns and cities undergoing a critical housing storage or those which are in the process of industrial expansion would naturally provide a fruitful field for RMC operation. However, with increasing confidence amongst architects, engineers, contractors and the public in a product of guaranteed quality and offered at rates which are competitive enough to induce the adoption of RMC in preference to site mixed concrete, the demand will soar. The size should, therefore, be selected taking into account potential future increase in production. Layout. The plant layout should be so arranged that it satisfies the following considerations. Firstly, it ensures the maximum efficiency in operation. Secondly, it provides adequate space for the storage of materials, and thirdly, it does not hamper future expansion. Adequate space for the stockpiling of materials is very necessary to meet with the irregular supply of cement and aggregates. This calls for the provision of sufficient space to accommodate the storage of materials to provide for a reserve stock of cement and aggregates equivalent to 7 to 10 days normal consumption. Delivery of RMC. While ready-mixed concrete can be delivered to the point of placement in a variety of ways, the overwhelming majority of it is brought to the construction site in truck-mounted, rotating drum mixers. Truck mixers have a revolving drum with the axis inclined to the horizontal. Inside the shell of the mixer drum are a pair of blades or fins that wrap in a helical, spiral configuration from the head to the opening of the drum. This configuration enables the concrete to mix when the drum spins in one direction and causes it to discharge when the direction is reversed. To load, or charge, raw materials from a transit mix plant or centrally mixed concrete into the truck, the drum must be turned very fast in the charging direction. After the concrete is loaded and mixed, it is normally hauled to the job site with the drum turning at a speed of less than 2 rpm. Since its inception in the mid-1920s, the traditional truck mixer has discharged concrete at the rear of the truck. Front discharge units, however, are rapidly becoming more popular with contractors. The driver of the front discharge truck can drive directly onto the site and can mechanically control the positioning of the discharge chute without the help of contractor personnel. Currently, because of weight laws, the typical truck mixer is a 9 to 11 cubic yards unit. Water should not to be added to the mix unless the slump is less than that which is specified. If water is added, it should be added all at once and the drum of the truck mixer should be turned minimum of 30 revolutions, or about 2 minutes, at mixing speed. The ASTM C94 specification for ready mixed concrete indicates that the concrete shall be discharged on the job site within 90 minutes and before 300 revolutions after water was added to the cement. Advantages: RMC is more advantageous to the consumer from both the technical and economical aspects of concrete making. Assures consistent quality through accurate computerized control of aggregates and water as per mix designs. It facilitates speedy construction through programmed delivery at site and mechanized operation with consequent economy. Elimination of material storage on congested building site. No need to allocate place at site for storage of cement, aggregate, sand. It minimizes cement wastage due to bulk handling and there is no dust problem and therefore pollution-free. Save contractors time, usage of labor's energy to mix concrete and also saves project time. Multi-transportation of raw materials. Creates a clean, pollution-free, noiseless and dustless environment. Disadvantages: double handling results in additional cost and losses in weight. Requirement of go-downs for storage of cement and large area at site for storage of raw materials. Aggregate get mixed and impurities creep in because of wind, weather, and mishandling at site. There are always the possibilities of manipulation, manual error, and mischief as concreting are done at the mercy of gangs, who manipulate the concrete mixes and water-cement ratio. How much concrete in a RMC truck? Regardless of size, you need to calculate the volume of concrete in cubic yard or in cubic meter, M3, before ordering the mixed concrete. Volume is calculated by multiplying length, width, and depth as length times width times depth, add extra at 10%, so total required concrete quantity is volume plus extra 10%. So you should remember in general ATM or RMC truck shall carry 6 m3 of concrete, which is equal to 212 cubic feet. Mathematical calculations such as 1 cubic meter equals 35.3147 cubic feet, so cubic meter to cubic feet as 6 times 35.3147 equals 212 cubic feet. If you want to calculate in metric ton, then multiply total M3 with 2400, density of concrete in kg M3, such as 6 times 2400 equals 14,400 kilograms, which is approximately equal to 14.4 mt. So you should remember, in general, ATM or RMC truck shall carry 6 M3 of concrete, which is equal to 212 cubic feet. Mathematical calculations such as 1 cubic meter equals 35.3147 cubic feet, so cubic meter to cubic feet as 6 times 35.3147 equals 212 cubic feet. If you want to calculate in metric ton, then multiply total M3 with 2400, density of concrete in kg M3, such as 6 times 2400 equals 14,400 kilograms, which is approximately equal to 14.4 mt. Thanks for watching.
For now, please subscribe, like, share and do not forget to press bell icon.